Hi students, this is Sivakumar, 11th Standard Mathematics, Chapter number 1, Continuation of Exercise 1.3. Now problem number 3. You are given f of x, different f of x in different intervals. You are asked to find f at minus 3, 5, 2, minus 1 and 0. Okay. So here is the question. Here we have the question, third question. First we can draw a number line. Here minus infinity, plus infinity. We have different numbers 0, 3 and 2. Apart from minus infinity and infinity, 0, 3 and 2. So we have to write them in order. 0, after that 2, then 3. Right? First interval, look at that, minus infinity to 0, we have x square plus x minus 5. Here, x square plus x minus 5. Next, we have the interval, consider this one, 0 to 2. 0 to 2, we have x square. 0 to 2, we have x square. Next one, 3 to infinity. 3 to infinity, we have x square plus 3x minus 2. 3 to infinity. Here, x square plus 3x minus 2. Otherwise, 0 here. Sorry, not 0. Otherwise, you are getting x square minus 3. Otherwise means which one is left out here? Here only. So, in this interval, x square minus 3. Okay. Now we can do one by one. For f of minus 3 first. Therefore, f of minus 3 equals minus 3 obviously lies in this interval only. Minus infinity to 0 only, you will be getting minus 3. So I have to consider this f of x. So replace x by minus 3. Minus 3 the whole square plus of minus 3 minus 5. Minus 3 the whole square is 9. Plus into minus minus 3 minus 5. 9 minus 3 is 6. 6 minus 5, that is equal to 1. Then you have to calculate 5. F of 5. 5 lies in this interval, lost interval. So I have to consider this f of x. Replace x by 5. 5 squared plus 3 into 5 minus 2. 5 squared is 25. 3 5s are 15 minus 2, that is equal to 40 minus 2, that is equal to 38. Next one, you have to find f of 2. F of 2. Here 2, look at that, 2 is here. We have to verify that 2 lies in this interval or in that interval. How to verify? Look at the question. Here only 2. But 2 has been excluded. Look at that. It is a right open bracket. Suppose you are given this type of bracket. This is right closed bracket. Look at the difference between these two brackets. For this bracket, this number has to be excluded. If you are given this type of bracket, that number has to be included. Okay. So 2 has to be excluded in this interval. So which one to be considered? So we are not supposed to consider 0 to 2. So have to consider only 0 to 2 are not supposed to consider. You have to consider only 2 to 3. In this interval, what is f of x? X squared minus 3. Okay. And this interval is connected with 2. So x squared minus 3. X should be replaced by 2. 2 squared minus 3, that is equal to 4 minus 3, that is equal to 1. Next one, you have to calculate minus 1. F of minus 1. Minus 1 obviously in this interval, first interval. So I have to consider this f of x. Replace x by minus 1. Minus 1 the whole square plus of minus 1 minus 5, that is equal to minus 1 the whole square is 1, plus into minus 1 minus 5, 1 minus 1, 1 minus 1 get cancelled, we'll be getting minus 5. Finally have to calculate 0, f of 0. Here we have 0, so that you have to consider that 0 lies in this interval or in that interval. So go here, we have the function 0 here, here also we have 0. Okay, in both the cases 0 has been excluded in both the cases, because you have that look at the bracket. Since 0 is not in any of the two intervals, look at the bracket, right open, here left open. Already I told you for this bracket that number has to be excluded. Here also have to exclude, here also have to exclude that. So that which interval to be considered, which function to be considered, otherwise only. For 0 have to consider this function, what it is, x squared minus 3, remember. Okay, so x squared minus 3. At the same time 0 won't be in this interval. 0 is not here, 0 is not here, 0 is not here, so have to consider this function only, x squared minus 3. So x squared minus 3, what is the value of x? 0. 0 squared is 0, 0 minus 3, that is equal to minus 3. So problem number 3 is completed. I'll be teaching that next problem, that is problem number 4, in the next video. Thank you, children.